Hi everyone, welcome back to my channel. I'm Sharanya Velamuri and today we will be discussing about graphs of motion for IGCSE students. So without further ado, let's begin. Alright, so firstly we're going to have a look at distance time graphs. The first thing we have to understand is that the gradient of each graph tells us how to interpret them. Now what is a gradient? A gradient is a slope of a graph. Alright, it is calculated by dividing the change in the y value by the change in the x value. So let's write down the equation. Gradient is equal to change in the y value upon change in the x value. Alright, let us look at the graph on the screen. We have the distance on the y-axis and the time on the x-axis. Here, the line is horizontal. There is no change in the y value, that is the value of distance, and only the x value is increasing. Therefore, the graph isn't sloping. It is a horizontal line. This means that the gradient is 0, denoting that the object is stationary. Alright. So, horizontal line shows object is at rest or stationary. The object does not cover any distance as time passes. This means that suppose this is 1 second, this is 2 seconds, this is 3 seconds, and this is 4 seconds. Alright. So at 1 second, we have this value of distance. At 2 seconds, we have the same value of distance. At 3 seconds, the same value, and at 4 seconds, also the same value. Time is passing, but the object is not covering any distance. Hence, the line is horizontal. It shows that the object is at rest. Now, let us move on to the next slide. Look at these three graphs on the screen. Here, the y value is changing in constant proportion to the x value. All the graphs are straight lines sloping upwards or downwards, meaning that the gradients are constant. Let us look at the first picture. The graph is a straight line going upwards. This shows constant speed. Constant speed. It also shows that the object is moving forward. Now let's look at the second graph. The second picture also shows a constant speed, but this speed is slower than that of the first graph because the gradient is less steep. So let's write it down here. Alright, now let us look at the third graph. It is a downward sloping straight line. This also shows constant speed, but it denotes that the object is moving back to where it started. In these graphs, we are talking about the distance moved by an object from a particular point. In essence, we are talking about displacement. This is one instance where distance is used in place of displacement. So let's write down. So this is a summary of everything that we discussed in this slide. Now let us look at these two images. In these images, the graphs are curves, means that the slope is not constant. This means that the speed is changing and the graph shows acceleration. In the first one, the gradient is constantly increasing, meaning the speed is constantly increasing, showing acceleration. Alright, now let us look at the second one. The gradient is constantly decreasing, meaning that the speed is constantly decreasing, and this graph shows deceleration. This is a summary of everything that was discussed in the slide. Now let us move on to speed time graphs. These graphs have speed or velocity in the y-axis and time on the x-axis. Here, in the speed time graph, the gradient of a speed time graph denotes acceleration. So let's note it down. The gradient of a speed time graph denotes acceleration. Alright, now let us look at this graph. Here, the graph is a straight line going upwards, meaning gradient is positive. It shows acceleration, which means an increasing speed. It shows an increasing speed. So as you can see, for 1 second, the speed is 20. For 2 seconds, the speed is 40. It has increased by 20. For 3 seconds, the speed is 60. It's increased by another 20. And for 4 seconds, it's increased by another 20, making it 80. So acceleration at a constant rate. So you can write constant acceleration, because speed is increasing in proportion to time. Every second, speed is increasing by 20. So if the gradient was negative and the graph was sloped downwards, it would be a constant deceleration. Let us consider the two graphs shown on screen. Here, the graphs are curved, means that the slopes are constantly changing. This shows non-uniform change of speed, means that the change of speed is not constant and changing per unit of time. Let us look at the first graph. This graph shows non-uniform acceleration. Non-uniform acceleration. That is, an increase in speed at a rate that is not constant. The second graph shows non-uniform deceleration. Non-uniform deceleration. That means a decrease in speed at a rate that is not constant per unit time. This concludes the chapter describing motion. Thank you so much for watching. I hope you enjoyed this video. Please like, share and subscribe. Thank you.